Welcome to Chapter 4, Compounds and Their Bonds. This video is on Chapter 4.5, and this is going to be about covalent compounds. Okay, covalent compounds are formed when atoms of two nonmetals share electrons. Because of their high ionization energies of the nonmetals, electrons are not transferred between the atoms, but they are shared to achieve stability. So this is different from the ionic compounds that we have looked at. And so when these atoms share electrons, the bond is a covalent bond. And when two or more atoms share electrons, they form molecules. And what we're going to learn to do is we're going to learn to draw these molecules. And we're going to learn to represent these bonds and the electrons in them and learn to draw these formulas. So what I just said, basically covalent compounds share electrons and they include nonmetals. We've learned, so here in a few minutes you will, or not a few minutes, maybe whenever on your time that you want to look at the naming nonmetals video, you will learn to name these as well. Okay, I think it'll be the next video in the sequence. And these come from groups 4, 5, 6, and 7 because these are our nonmetals, group 4A, 5A, 6A, and 7A. Okay, one thing to remember as we're going along is that each bond, each covalent bond contains two electrons. So if we have a hydrogen molecule, which is the H2, so we have two hydrogens, it forms as the atoms move closer and the nucleus of one atom attracts the electron of the other. Okay, so we're looking at the electrons, and it's stable with two electrons because hydrogen just has one, right, because its atomic number is 1. But it would like to have two, like helium. And so it's going to share a pair of electrons. And in that bond, it's going to contain two electrons. So here's two hydrogens far apart. When they come closer together, the attraction pulls them closer. And then they form an H2 molecule. So we consider it to be a molecule once they combine. And we also would represent this, so they're sharing. So here's where they're sharing their electrons so that they have two, which is what they want. They want two to be like helium. We also write this like this as well. This bond represents two electrons, just like we see there. Okay, we could do the same for fluorine. So fluorine wants to gain an electron. So if we have two fluorine atoms, they're going to come closer and closer together until they form or they share a pair of electrons to make a covalent compound. Okay, and so they share. So here they're going to share this. So now both fluorines are happy. They're satisfied. They have 8 electrons around each. So 2, 4, 6, 8. 2, 4, 6, 8. Okay, so each has 8. And we can also write this as this. This is called a covalent bond, and it represents these two electrons. Okay, those electrons are bonding because they're in the bonding, so involved in bonding. So these will be bonding, and then these are called, all of these here, so all of these, and on the other fluorine, these are non-bonding, also known as lone pair electrons. Okay, so these are very simple electron dot formulas, but we're going to look at more complex ones here next. Okay, so your book goes through and it kind of gives, it's a little vague on how to write electron dot formulas. We also call these Lewis structures, so if I use that term, that's what I'm referring to, is drawing the Lewis structure or the electron dot formula. I'm going to show you a system that helps you keep up with your electrons, and I feel like gives you more of a systematic way of coming up with the formulas for covalent compounds. Okay, we're first going to look at methane. So it's CH4, and I've already got it drawn over here. Okay, but we're going to look at how do we get this? How do we come up with methane has the formula that looks like this? Okay, so one thing we want to be sure we know, these two electrons are in this bond, these two here. So each bond represents 2 electrons. You really can represent 2 ways. You can show the line or you can show all of the electrons. I'm used to showing the line, so I'm going to show it. So each bond contains 2 electrons. Okay, what we do, we have CH4. We're going to use a method called the NASB method. Okay. N stands for needed. A stands for available. S stands for shared. And B for bonds, or the number of bonds. Okay? Alright, so if we look at needed electrons. Okay, so we've got a carbon and we've got 4 hydrogens. So carbon, it wants to obtain 8 electrons. So all of your elements besides hydrogen need 8. They want to fulfill their octet. So for carbon, we need 8. For hydrogen, it's our exception because it only needs 1 electron to be like helium. So for hydrogen, we need 2 electrons, but we have 4 hydrogen atoms. So we have 2 times 4. Okay, here we just have 1 carbon, so it's just times 1. Plus 2 times 4. Okay, so we have 8 plus 8 gives us 16 electrons. And once again, we're bookkeeping electrons. That's what we're looking at. Okay, available corresponds to the valence electrons. So we can come up with this by looking at our periodic table and what group that we are in. Okay, so if we find carbon, it's in group 4. So it has 4 electrons. I probably need to be writing electrons because that's what we're talking about here. Okay. And hydrogen just has 1. Okay, it has atomic number of 1. It's in group 1. Okay, and so it's going to have 1 electron. But we have 4 hydrogens, so we have to take into account 4 hydrogen atoms. So we have 4 plus 4, and that gives us 8. Okay. Available is going to become very important. Okay. For shared, okay, this is going to be equal to needed minus available. So 16 minus 8 equals 8 electrons. That means we are going to be sharing in covalent bonds 8 electrons. Okay, if every bond contains 2 electrons, then our number of bonds, so these two kind of go hand in hand. Okay, so we're going to make 4 bonds. Okay, so now we are going to, we have carbon and we have 4 hydrogens. You have to match your formula. You can't draw 2 carbons or 6 hydrogens. You have to have the correct number of carbons and hydrogens. Okay, carbon always wants to be in the middle. So if you want to remember this as a little tip, always wants to be central, and it makes 4 bonds. This is just a little tip to remember. Okay, and so if we draw 4 hydrogens around our carbon, our formula matches. We have CH4 and we have CH4. But now let's go check our NASB. Okay, we need 4 bonds. So we've got 4. We've got 1, 2, 3, 4. Okay, each bond contains 2 electrons. Okay, so we're going to have 8 shared electrons, 2, 4, 6, 8. Okay, and then we're going to add up the electrons in our total molecule, okay, and we need it to match the number of available electrons. So we need to match 8. So it looks to me like we've only got just what's in our bonds. So we've got 2, 4, 6, and 8. So we have 8 electrons represented, and it should equal our available electrons. So this is the correct formula. Okay, our next problem we have is NCl3 and H2O. So those are our next two. So let's just kind of so in CH4, all of our electrons were bonding. So if we look here, all of our electrons were involved in a bond. We have no non-bonding electrons hanging around. Okay, for NCl3, let's go through our process. So we have N, A, S, C. Okay, needed, all elements besides hydrogen need 8, and you have to account for all of the atoms. So we have 1 nitrogen and 3 chlorines, so we need 8 times 4. We need 32 electrons, 1 for nitrogen, and then all the rest, 24 for the chlorine, 3 chlorine atoms. Okay, available, this is our valence electrons. Nitrogen is in group 5. Okay. Has 5 valence electrons. Chlorine has 7, but we have 3 chlorine atoms. So this 3 comes from here. So we have 21, and we have 5. Okay, so we have 26 available electrons. This is what we're going to come back and check our answer with. Okay, now we have to look at the shares. So we need 32 minus 26. We have 6 shared electrons, 6 divided by 2. We have 2 electrons in each bond, gives us 3 electrons. Okay. So we're going to set up, we're going to put our nitrogen in the middle, our chlorines around. A little tip here, the least electronegative element goes in the center. Okay, it's pretty easy to see this, that you have to put the nitrogen because it has 3 chlorines, but just a little tidbit, so you haven't really talked about electronegativity too much yet. However, you can look at the next video. It'll be the section 4.8 on electronegativity. You can watch that, 4.6, or you can go stop the video right now, read that section if you'd like, just to clear up what electronegativity is, or you can watch the video if you want to. But the least electronegative element goes in the center. Okay, so this will help you later when you understand electronegativity. Okay, so we put our 3 bonds around, so let's make a checklist here. So we've got, if we look up at our NASB, we need 3 bonds. This B stands for bonds. Okay, well when we plugged all these around, we have 1, 2, 3 bonds, which means we have 6 electrons. Those go hand in hand, 2 electrons in each bond. So we need 26 available electrons to be represented in our structure. Okay, we know that all of our atoms want to have 8 electrons around them, except for hydrogen, just wants 2. So what we do is we fill in the electrons around surrounding our outer atoms first to give them 8. So if we count around our chlorines, we have 2, 4, 6, 8. You can do that for the other 2. Okay, now let's add up the electrons represented. We have 2 in this bond, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, but we still need 2 electrons. Okay, and so once you've filled in the outer atoms, you're going to come back to your central atom and place the electrons on the central atom. Now we have 26 electrons. So these would be considered bonding, and this is considered a lone pair of non-bonding electrons. Okay, we'll do the same for water. We have 2 hydrogens. Hydrogens want to have 2 electrons, not 8, are the only exception. Oxygen wants 8, so we get 12 electrons. Available, okay, hydrogen has 1 electron, and we have 2 of them. So this 2 comes from the 2 in our formula. And then oxygen is in group 6, and so it has 6 valence electrons. Okay. So if we take 12 minus 8, gives us 4 electrons and 2 bonds. Okay. So oxygen, hydrogen never wants to be in the middle. So hydrogen never wants to be central, or the central atom. Okay, because it only wants 2 electrons. It doesn't want any more than that. So oxygen is going to go in the middle. We have 2 bonds, which makes sense here. We've got to have 2 hydrogens. Okay, but we only have 4 electrons represented. 2 in this bond and 2 in the bond on the left. Okay, but we've got our bonds, and we have 4 sharing electrons. But we need 8 electrons represented. Okay, we cannot put electrons around hydrogen like we did over here with the chlorines. Okay, we went to the outside and we added electrons. Okay, if we do that here and we add electrons, what are we doing to hydrogen? We are making it have 4 electrons, and it does not want to have 4. It wants, hydrogen needs 2. Okay, so it's got its 2, right? Here's 2 electrons. So it is happy. Okay, so you will never see this or this, okay, when it's bonded to something else, okay, or any of the variations of that. Okay, so what we have to do is we have to go to our central atom because we cannot fill in any more electrons around the oxygen, so we have to go to our central atom, and we are going to have to place 2 pairs, 2 lone pairs. So this is the structure of water. And we'll talk about later, the structure is what makes it polar. Water is very polar, and so these are very important when determining polarity of molecules. Okay, so real quick, let's check. We've got 8 electrons. We have 2 in this bond, 4, 6, and 8. Okay, we're going to have situations where we have double bonds and we have triple bonds. So when atoms share 2 pairs of electrons, and this happens when there's not enough electrons to complete the octet. And we'll show that here in a minute. But a triple bond is when you have 3 bonds to an atom, and so the same reason applies there. So we're going to look at how we can draw these. Okay, if we have, I'm going to do all 3 of these for practice. So we're going to do CO2, 2. Okay, so we're just going to do 2 here. Kind of put them a little too close together. So we have CO2, so you can go ahead while I'm erasing here and start thinking about how you would set this up. So we have needed NaSB. We have 3 atoms that are not hydrogen, so we know that we're going to need 8. Remember, that's our octet. That's our magic number. Times 3, because we have 1 carbon, 2 oxygens. So we have 24 electrons. Available, we look at the group number for our valence electrons. So carbon's in group 4. We just have 1 of those. And we have oxygen, which is in group 6, and we have 2 oxygens. Okay, 24 minus 16 gives us 8 electrons, and we're going to have 4 bonds. Okay, we know that carbon wants to be in the middle. Okay, but now if we look here, previously when we've just drawn our structure, just basically just through, common sense of how we have to arrange it, then now we need 4 bonds, but we only have 2. Okay, so what in the world can we do? And we also know carbon always wants to make 4 bonds, so that's another hint there. We've only got 2 bonds around carbon. Okay, so all that we can do in order to meet this 4 bonds is to add a bond here as well as a bond here. Now we have 4 bonds and 8 electrons shared. Okay, but we have to match up our electrons that we are going to represent. We need 16. So we can't forget that we need 8 around each atom. So we fill in the electrons around oxygen. So we have 2, 4, 6, 8. Each bond representing 2, 2, 4, 6, 8. 8 on one side of the carbon, 8 on the other, and we're left with 16. Another example is N2. So if we come up with needed, we just need 8 times 2. Available nitrogen is in group 5. We need 5 times 2 or 5 plus 5, however you want to look at that. We need 3 bonds. Okay, so why is this important? If I hadn't taken chemistry and I was to just try to draw into, I would probably just do this. And that's what I would think that the compound would exist. That's what I would think it would look like. Okay, but in reality it's not, because this, we are not fulfilling the octet rule. Okay, so if we draw our 2 nitrogens, we know that they've got to be bonded together. Okay, and we need 3 bonds. We only have 1. So all we think that we could do is we've got to add 2 more to give us the 3 bonds. Okay, and now we look at each nitrogen separately. So we've got 2, 4, 6 electrons shared in the bonds, but we need 8. Okay, so we're going to need another pair of electrons on each of the nitrogens. So now we have 2, 4, 6, 8, 10 electrons. So always go back to your available electrons and make sure it matches your structure. This concludes the video on electron dot formulas.